Hi, my name's Claire Weber. I'm a clinical solution architect with physIQ, and today I'm excited to give you a glimpse into how our solution can be used in the oncology setting, and more specifically, immuno-oncology. CAR-T therapy is a life-saving cancer treatment that comes with serious risks, such as cytokine release syndrome. What if you could mitigate that risk through personalized predictive safety monitoring? That's where physIQ is doing some really exciting work. Let's take a look. physIQ's continuous remote safety monitoring solution leverages our AI-based digital twin model. So let's break that down. To apply this technology, we start with a 48-hour baselining period. During this time, the system uses advanced algorithms to understand the individual's unique physiology and develop a digital twin of the patient. When baselining is complete, the platform then switches to safety monitoring mode, using comparisons to the learned digital twin to watch for physiological changes following the infusion of a CAR-T therapy. We'll continue to measure that individual's actual physiology in near real time, for example, measuring his or her heart rate, respiratory rate, heart rate variability at that moment, while at the same time continuously projecting modeled estimates for each of those parameters based on that patient's digital twin. This allows physIQ to make a U-to-U comparison of interactions between ongoing vital sign data and expected personal norms, not population averages. By analyzing the differences between the actual and the expected in one's physiology, we can establish a scaled index that picks up on subtle changes that may be clinically significant for that individual and an early sign of decompensation. This digital twin approach has a wide range of potential applications, one of which is detecting signatures of inflammation. It's our inflammatory multivariate change index, shown in this graph in red, that allows us to detect inflammation, an early sign of CRS in patients receiving CAR-T immunotherapy. Here, we're looking at one CAR-T patient being monitored using physIQ. Each lane shows one of the physiologic parameters being continuously monitored. We can see both the actuals in blue and the estimates in yellow for their heart rate variability, their respiratory rate, even their temperature. This patient received a CAR-T infusion on May 18th, and their temperature was taken regularly, as is the standard of care for detecting CRS. The patient eventually had a fever on May 23rd, shown with the blue line, and was treated for CRS and eventually recovered. However, as shown in this case, physIQ's inflammation index picked up on subtle deviations between the actual and the expected physiologic markers and generated an inflammation signal that preceded a temperature-based CRS diagnosis by approximately 50 hours, a major improvement on the standard of care. This early detection has the potential to redefine the immunotherapy care paradigm by making it safer, less expensive, and more accessible by allowing for home-based monitoring following one's therapy. Near real-time continuous safety monitoring is just one use case in oncology. There are broader opportunities to leverage physIQ for adverse event detection, cardiac and functional capacity measures, dose optimization strategies, as well as objective quality of life measures. Thanks for watching this video, and we look forward to continuing the conversation.